Module 9, Lesson 4 covers volume. According to the textbook, this is a 2-day lesson. If we look at it, we've got 19 different resources to get through, so that's probably going to be a 2-day lesson. Volume. Joel's Delicious Popcorn makes gourmet popcorn in several different flavors. They sell their popcorn in tins that come in many different shapes and sizes. All of the tins are in the shape of a rectangular prism with different dimensions. The popcorn tins at Joel's Delicious Popcorns are rectangular prisms. However, the tins do have different dimensions. They did tell us that already. The table shows the dimensions and the cost of the smallest and largest tin of popcorn offered. How can you determine which tin holds more popcorn? How can you determine which tin offers a better deal? These are some of the things we're going to be learning about in today's lesson. Let's start off by actually defining what volume is. Volume of a three-dimensional figure is the measure of the space it occupies. You are a three-dimensional figure. You have volume. An easy way to determine that volume would be to take a tank of water like your bathtub. If you ever notice when you sit in the bathtub, the water level rises. Well, the difference between the top of that water and the bottom of that water when you come out of the bathtub, where the high and low spots are, that is the volume that you displace. The amount of water you displace is your volume. It is measured in cubic units such as cubic centimeters or cubic inches. Select a card to learn about the formula you can use to find the volume of a prism. And we do need to understand a rectangular prism has two parallel and congruent bases that are going to be rectangles. Go ahead and define that. And then a triangular prism has two parallel and congruent bases that are going to be triangles. Go ahead and define that. Now, if we were to look at that in words, we would see that the volume of a prism is going to be the product of the area of its base. That's a capital B. That capital B we refer to as base area. And its height, the little h, is going to be the height. The reason we make that one capitalized is because it's a big concept and we have to do other work to get to it. Volume is also going to be a big concept. It gets capitalized. Height is just an insignificant little thing, so it's not that important. Looking at it as a model here, you can see that you've got a base on their prisms. The base area is the area of the base times the height of the prism. The area of the triangular base on this one times the height of the triangular prism. And then with symbols, you could see the formula for it is volume is equal to base area times height. Let's see if we can apply this to a real-world problem. The jewelry box is the approximate shape of a rectangular prism. Now, it looks funky because they have the drawer out, but it's still just a rectangular prism. What is the approximate volume of the jewelry box, round to the nearest tenth if necessary? And we're going to be using that same formula that we've talked about here. Volume is equal to base area times height to solve it. So the first thing we're going to need to do is find out what the shape of the base is, and then we're going to need to find the area of that base. It's otherwise known as the base area. And what are they going to do? Oh, here we go. So I don't like how they're showing their work at all on this, so let's take a break here, and I'm going to redo this on my own paper because the way I'm going to show you, it's just a whole lot better. Alright, so here's my drawing, and I'm going to take and come over here and actually draw in a kind of rectangular shape that is going to represent where the base is on that. Now, I know that's not perfect, get over it, but we have a rectangular base, and this distance right here corresponds to that distance right here. So I'm going to have an 18.4 centimeters by a 14.8 centimeters. And then I'm going to use a formula. Now, it's a rectangle, and remember the area of a rectangle could be listed as length times width. And instead of area, I'm going to change that to a capital B for base area, and it's still a rectangle, so we're still going to be doing length times width. Base area is going to be equal to 18.4 times 14.8. Therefore, the base area is going to equal 2. And I don't want to eat up all of our time showing you how to do these by hand. So we're just going to knock this out. 18.4 times 14.8. That means you're going to have a base area of 272.32. Now we're going to circle that even though it's not our final answer. To get to the final answer, we need a whole new formula, and that formula is volume is equal to base area times height, where the base area we just found is 272.32 times the height. That's going to be this distance right here. That's going to be 25.6, the height of the prism. And when we take and multiply that out, we're going to do times 25.6, and that's going to give us 6,971 point, rounded to the nearest hundredths, 39. Actually, I think that said the nearest tenth, didn't it? Which means we're going to actually do that to 0.4. So 6,971.4 cubic centimeters will be our answer. Jump back over to our problem, which is right here. And you can see that's exactly what they came up with in their problem. They included the base area in their formula right here. They said just took base area and boom, threw in a length times width for it. I don't like doing that. I like to make my base area a totally separate part, and then I do my height for the volume to go with that. Either way, makes you happy. You can take and put your 6,971.4 rounded to the nearest hundredths, and that's going to give you happy sounds for a good answer. For extra example 1, we have another rectangular prism here for the school trophy case, and they want to know what the volume of it is. I would like for you to pause the video and work this, and I want you to work it the way I showed you. Find the base area first, and then find the volume second. Go ahead and do that right now, and I'll let you use a calculator on it just because I'm feeling generous today. Alright, so I have my image, and I went ahead and wrote the formulas I'm going to need. I'm using the rectangular formula for area of a base of a rectangle, so that's base area equals length times width, and what we're looking at is this rectangular base that we have right here. From there, I'm going to take, hold on, Siri's giving me issues. Every time I say base area, if I say it too quickly, she thinks I'm saying, hey, yeah, you know. Now, this distance we have is 5, but this distance right here, that corresponds to this distance right here. So, to find the base area, I'm going to get a length of 5 times a width of 3, which means I'm going to have 5 times 3 is 15. I'm going to circle it, not because it's the answer, but it is an important sub-answer. Next, I'm going to come over to the volume. I'm going to plug in what I know, which is that the base area is 15, and the height this time, that's this number, the height of the entire prism. That's going to be 9.5. So now volume is equal to, and we'll just go ahead and do that on the calculator real quick to save you all time. 15 times 9.5 is equal to 142.5, which is an exact answer. How do they want us to round our answer? They didn't say, so 142.5, check, and it checks. This right here is going to be your supporting work. That's what I'd have to see for you to earn credit for that problem. Our next problem involves a triangular prism, and the first thing we have to understand is that the base is not what it's sitting on. If we focus on what it was sitting on, it would probably be that. The base is going to be the triangular pieces, and the height, that's going to be the distance between our triangular pieces. So to find the volume of it, nope, they went ahead and made those big scary leaps. I'm not going to do that. I'm going to make a screenshot, and we're going to walk through it the same way we did the other. We're going to find the base area first, and after we find the base area, then we're going to take and find the volume. So paste it in, and let's start off with the area of the triangle. So the formula for area of a triangle is base times height divided by 2. So for this one, I'm going to say that the base area is also going to be base times height divided by 2. But the height I'm talking about is the height of the triangle. So I'm going to have the base area is equal to, I've got a base of my triangle right there, 6.5 times a height of my triangle right here, 8.25, all divided by 2. From here I can say base area is equal to, 6.5 times 8.25, 6.5 times 8.25, that's going to end up giving us 53 point, I believe it was 625 divided by 2. Is that what it was? Yep. And then we're going to take that, divide it by 2, and that means we're going to have a base area is equal to 26.8125, and we're going to circle it. Not because it's the answer, but it is an important sub-answer. Now we have to find the volume of our prism, which is base area times height. Volume is equal to, the base area we came up to is 26.8125, and the height, that's going to be this distance right here. The distance between our parallel triangular bases, that's going to be 15.3. From here, volume is equal to, come back over to our little pocket Satan, times 15.3. And when we do that, we get 410.23125, 23125. And I want to look at my instructions again. How do they want us to round it? They want us to round it to the nearest hundredth. So that means volume is going to be about 410 point, that's my hundredths place, 23, no rounding up required. Jump back over here to check it, and we can see that they do the same thing, 410.23, and checks, and the answer checks. Once again, I don't like them including the whole base area into the other formula, finding it there. Do those as two separate parts. Once again, it's going to be your turn. Go ahead and pause the video and work on this problem on your own. Alright, so the base area again is going to be the area of the triangular bases, and you remember your base height for your triangular area is always going to meet at right angles. So I'm looking at 6.5 times 7 divided by 2. And I've got options here on how I want to do this. I'm going to take and go ahead and do some simplifying here before I do anything. I'm going to take and say that 2 goes into 2 once and 2 goes into 7 3.5 times. I know that ended up being a decimal, but it's something I could easily do in my head, and it will save me from doing some other stuff later. So we're going to go ahead and do that, particularly since we already had decimals in the problem. Now all I have to do is take and do that last little piece of multiplication on that one. So I'm going to take my 6.5 times my 3.5. It's over 1, so it's just going to be that answer, 22.75, and that is going to end up being my base area, or the area of the triangular bases. Now I'm going to take and plug that in to find the volume. Volume is equal to, the base area we found is 22.75 times the height. That's going to be this distance right here, the distance between my triangular bases, which is 5.2. Volume is equal to, jump back over here again, times 5.2, enter. We're going to have 18.3, and that's cubic millimeters. So now we can jump back to our textbook, type in our 118.3, check it, and the answer checks. Easy math. That right there is going to be showing your work, folks. That is exactly what I'm expecting to see when you do these problems. This is looking like a really good spot to stop part 1 of this video. When we come back to part 2, we're going to learn how to find the volume of pyramids, which is going to take things in a whole new direction. I will see you in part 2.